Open a map of the Bay of Naples, and you'll see two neighboring towns, Pompeii and Herculaneum, struck by the same volcano, yet leaving different clues about how Vesuvius victims actually died. Start with the method. Archaeologists read bodies, deposits, building damage, and micro-traces. Then test explanations against what the layers and objects really show. At Herculaneum, early, superheated ash cloud surges blasted into sealed spaces near the ancient shoreline, displacing oxygen and delivering lethal heat in moments. Skeletons cluster in boat shelters and adjacent rooms with valuables still on belts and infants held close, a pattern that signals sudden death rather than a prolonged struggle. Wood around them is carbonized in place, and metal fittings are heat-warped, consistent with rapid thermal exposure in an oxygen-poor surge. That is why many specialists describe Herculaneum-HS's last minutes as dominated by thermal shock from pyroclastic surges rather than smoke or slow-burning fires. Forensic studies even document rare heat effects on soft tissues, strengthening the case that superheated air, not flame, ended life almost instantly. The result is a sealed archive where organic materials survived and where positions of bodies and objects remain legible. Pompeii, by contrast, records a longer disaster that began with hours of pumice fall and ash drifting down through the streets and onto roofs. Roofs and upper stories failed as lightweight debris piled up, blocking doors, jamming streets, and trapping people behind thresholds they could no longer open. Many victims there died from impact or entrapment under structural collapse during the pumice fall phase. Air quality inside houses deteriorated as fine ash and gases filled rooms. Breathing slowed, vision dropped, and asphyxiation followed in enclosed spaces. Only later did fast surges sweep across the city to deliver the same kind of lethal heat that Herculaneum felt earlier. That is why answers to how Pompeii victims died must include several mechanisms operating in sequence rather than one simple cause. When you map victims to rooms, streets, and doorways, the story becomes a timeline: early collapse and suffocation, then late-stage heat for those still present. The casts of Pompeii, formed where bodies decayed and left voids in hardened ash, preserve final postures that match this drawn-out crisis. Some people crouch in corners or cover mouths and noses, classic responses to choking dust in low-oxygen spaces. Others lie near blocked exits where pumice outside turned a doorway into a wall. Later, surge deposits cap those contexts and close the record with a final, hotter pulse. At Herculaneum, the signatures are different because the hazard was different. Surges arrived early, hot, and fast, packing voids and sealing rooms with only thin to moderate deposits in the first moments. People had little or no time to organize or flee, so bodies and belongings remain where daily life paused. This contrast, thermal shock at Herculaneum versus a spectrum of collapse, asphyxiation, and then heat at Pompeii, explains why two towns so close together preserve such different last moments. Temperature estimates from physical and chemical markers back this up, with ash cloud surges hot enough to kill instantly even inside buildings. Analyses of casts and bones at Pompeii add detail, indicating rapid suffocation for some groups before the hottest currents arrived. Stratigraphy ties those outcomes to the order of events. Pumice fall first, then multiple currents of ash and gas of varying density and temperature. Reading the disaster this way replaces myth with mechanism and shows how a volcano creates different lethal environments over just a few miles. It also explains why Herculaneum preserves wood, baskets, fabric, and food remains better than most sites, while Pompeii excels at showing city-scale plans and traffic. Both towns matter because they answer different questions when studied together. If your question is Vesuvius eruption death cause, start with hazard sequence and room-by-room context, not a single headline. If your question is Herculaneum victims forensic analysis, expect markers of instant heat in sealed spaces and minimal evidence of prolonged burning. If your question is Pompeii death mechanisms, Chart the locations of victims against roof failures, ash thickness, and late surge caps. Use the same logic for any natural disasters topic. Separate overlapping hazards by reading deposit order, body position, and damage patterns as one dataset. That is the evidence-first path to understanding Vesuvius victims without speculation. And that is how we can talk clearly about how people actually died at Pompeii and Herculaneum while keeping the focus on what the sites themselves still show. If you want a clean visual checklist that distinguishes thermal shock, ash asphyxiation, and collapse, with examples you can reuse across sites, stay with our channel for a focused follow-up that turns these field indicators into simple on-screen graphics.